I'm Anil Kumar. Welcome to my series on calculus. In this video, we will understand how to solve questions related to related rates. So these are application questions. You can treat this as a worksheet. We have 10 questions to begin with. You can always pause the video, copy these questions, try them out. I think you can see the first 5. Here are the other 5 questions. Now, once you're done with these solutions, then look into my suggestions. So let's begin with their solutions one by one. We'll try to understand the concepts involved as we move along, and we'll also focus on areas where you could make a mistake. Question number 1 here is, the side length of the square is increasing at the rate of 2 meters per minute. How fast is the area of the square increasing when the side is 25 centimeters? So we're talking about a square. It is always a good idea to make a sketch, right, of whatever the situation is, then define the variables. We say side length of a square is increasing at the rate of 2 meters per minute. That means side length we are interested for a square, all the sides will be of equal length. So let x be the length of a square at any instance of time, right? So that is how we define a variable. And when we say the side length of the square is increasing at the rate means with respect to time, right? So the units here is 2 meters per minute, right? So meters is distance, which is the length. So, and we have taken x as our variable, so we'll say dx, and that is a unit of time, so that is a rate. Since it is increasing, we'll keep this positive. So that becomes rate of change of distance with time. How fast is the area of the square increasing when the side is 25 centimeters? So we basically want to find how fast is the area. So let A be the area. When we say increasing, that means with respect to time. When the side is, that means this side x is equal to 25, and see the units are centimeters. This is what we need to figure out. Is that clear to you? Now, first thing is, you notice that the units are different, right? Meters and centimeters. So that is a common mistake. If you don't take care of the units, you will do a mistake, right? So if you're talking about rate in 2 meters per minute, it is a good idea to even convert this also in some units, which is similar, right? So let's say x is 25 centimeters, which is 0.25 meters. Is that clear to you? So converting units is the first step which you should be doing. You could have converted this to centimeters per minute also, right? Okay. Now we need to see what is the relation between area and the length here. And for a square, we know area is x square. So that is the relation. Now differentiate with respect to time. So we are differentiating with respect to time both sides. So we get dA dt equals to 2 times x dx dt. Perfect. We need to find dA dt, and we know what it is now since we have differentiated. So we could now write this as 2x times dx dt is given to us. The units are meters per minute. So 2x, we can write 2 here for the time being. Okay, and no harm in writing the units also as we move along. So, but x will also be in this unit, so I will write meter square here, assuming that we will be using x in meters, which we will definitely be using, correct? Now the question was to find this increase in rate with respect to time when x is 25 centimeters, which we know is equivalent to 0.25 meters, correct? So we can substitute this value here, right? So we get 2 times 0.25, which is 1/4, right, times 2, and that is meter square per minute. Meter from here and meters per minute from there, right? This is quarter, right? So we get just 1 1 meter square per minute, right? Per minute. Is that clear to you? So that is how we can find the rate of change of area in this particular case, right? So the area actually becomes 1 meter square per minute at this instance of time. Perfect. Let's take the second example, which is the side length of a cube is increasing at the rate of 10 centimeter per second. So now we've just changed it a bit. So gradually we are trying to have examples which can give you variety, right? That's the whole idea. So now we have a cube. The side length of a cube is increasing at the rate of 10 centimeters per second. So we'll just put x for length at any time, and side length is increasing, means it is positive. So dx dt is equal to 10 centimeters per second. Now A is, how fast is the volume increasing when the length is 5 centimeters? So we want to find dv dt when x is 5 centimeters. Same units, right? No problems here. So we have a relation between volume and the side length, and which is volume is x cubed, right? So differentiating with respect to time, we get dv dt equals to 3x squared dx dt, right? And now from here, we can always find the answer. We want to find dv dt, rate of change of volume, when x is equal to 5 centimeters. So x equals to 5, correct? Units are same, so I'm just writing 5 here. We'll just substitute the value of x. We know dx dt is 10, right? So we get 3 times, we know 5 centimeter, right? 5 centimeters square times dx dt is 10 centimeter per second. So purposely I've written them separate, and you can see it is cubic centimeters per second as the unit, right? So 5 times this becomes 25, 250, and then 750, correct? So we can write this answer here. We have to do part B also. Let me write down here. So this is 25 times 375, 750 centimeter cube per second. Is that clear to you? So that is how we are going to answer it. So this is our part A. Now let's do part B. Part B is, how fast is its surface area increasing when the volume is 100 centimeter cube? Now, so this is very tricky actually. We now want to find how fast the surface area. So surface area, let's say surface area, let me write like this, of a cube is what? If x is my side, there are 6 sides, so it is 6x squared. That is the surface area. So we have a relation between surface area and the sides, but says how fast is its surface area increasing when the volume is so much? Well, we should know volume of this is x cubed, right? But we are given 100 as the volume, and we want to find what is x, right? So let me make it 1000. Just to keep things simple, right? So I'm changing the volume, V equals to 1000 centimeter cube. So I'm just making this change because I want to keep calculations very simple, okay? So that is what is there. So from here, what we can see that volume equals to x cube means we are saying 1000 equals to x cube, and therefore x is cube root of 1000, which is definitely 10, right? So 10 centimeters is the value of x. Do you see that part? So we got this. Now it is much simpler. We know exactly what to do. We have to differentiate this with respect to time, correct? We also know, because this is a part of the first question, that rate of change of side length is still 10 centimeters per second. Perfect. So all this is given to us. Now with that in mind, let's find the rate of change of surface area with time. Now this rate of change is 12 times x times dx dt, correct? So now we know what is the value of x. So now we can actually calculate the change in surface area with time when x is equals to 10, because that is the point where volume is equals to 1000. Is that clear to you? Right? So that is what we have done. We made a small change just because we want to keep all calculations very simple. Okay, so this is 12 times x, which is 10 for us, and rate of change is also 10 for us, correct? Units. Now you can see definitely this is all centimeters, this is centimeters per second. So what do you expect? Centimeters square per second. So 1200 centimeters square per second. Clear? So move along with the units so that you're sure finally you include units in your answer and also you have the correct units in place. Perfect? Okay. Now let's take question number 3, which is radius of a circle is increasing at the rate of 4 centimeters per second. So that means dr dt, correct, is 4 centimeters per second. Find the rate of increase in area of the circle. We want to find increase in area of the circle that has area of 36 pi. Okay. So again, we know the relation. The relation for us is that area of a circle is pi r square. But here we are given the area. That means we need to find what should be the radius at this time. So using this area as pi r square, and we know area is 36 pi, right? 36 pi. We can find what r is, right? So it is pi r square. Now pi and pi cancel, and definitely radius has to be positive, and so we get square root of 36, which is 6. So r is 6 for us. So we basically want to find what is the change in area with time when area is 36 pi, or we can also say when the radius is 6. Does it make sense to you? This is what we need to find. Is that clear? Perfect. So sometimes directly the value is not given to you. You have to find it, right? Now let's solve this. Find the rate of increase in area of a circle that has given area, correct? So let's find rate of change. So we are given A is equals to pi r square. So dA dt, with respect to time, we are differentiating. So we get 2 pi power rule, right? R dr dt. Now to find the rate of change of area with respect to time, and we say r equals to 6, we'll substitute r as 6 here. So we get 2 pi times 6 times dr dt is 4. 4, correct? So we'll write the units later. We now have our answer, which is 6 times 2, 12 times 4, right? 48. So we have 48 pi, and the units will be rate of change of area, and everything is in centimeters. So it is centimeter square per second. Is that clear to you? So that becomes your solution. So we kind of did it in 3 parts just to show you that these are the steps involved when you're normally solving a question based on related rates. So write down whatever is given to us. So in the first part, we wrote what all is given and what we need to find, right? And what we need to find. And then we have to somehow relate, right? So we have to have a relation. So when you get the relation, then you differentiate and get your solution. Perfect. So if you apply this approach, it should not be difficult to solve these questions. Here is question number 4 for you. I'd like you to pause the video. I'll take a small break here, and then we'll continue with the other questions. During the break, I went cycling, and in a Humber trail, I was lucky enough to see a coyote. So I hope you enjoyed that glimpse and that looks. Now let's continue with questions. And here is a very relevant question to our situation. Question number 4. A bicycle has tires with radius 70 centimeters. Find the rate at which the tires turn if the bicycle is moving at the speed of 5 meters per second. Right? So think like this. That is the, I'm only making one tire of the bicycle, right? So that is the wheel we're talking about, right? So of course the other wheel will be similar, but we'll focus on relation. So as this wheel moves along this path, we travel some distance, and let's call this distance as x, right? So that is the distance. How is this distance related with the radius? Well, of course, this radius 2 pi r is the circumference, so this distance is related with the, as the wheels turn, it goes every cycle the same distance, right? So if we have n turns, so in the n turns, we reach a distance x. So x will be equals to 2 pi r, which is each turn, times n, right? So that becomes the relation between the distance and the number of turns, right? Now let's read the question once again. It says, a bicycle has tires with radius 70 centimeters. Find the rate at which the tires turn if the bicycle is moving at the speed of 5 meters per second. So here we are given that the radius is 70 centimeter, and we are also given that moving means change in distance, right? So it is dx dt, which is 5 meters per second. So that is given to us. We need to find the rate at which the tires turn. So in our case, dn dt, right? This is what we need to find. Is that clear to you? So since we already have a relation, it's much simpler. Now radius is fixed, right? Radius is fixed, it is not changing. So we'll keep it fixed, which is 70, right? So that is the value. Okay, so we can write this as, rewrite this. So we have x equals to 2 pi r times n. So rate of change with respect to time, which is the speed, will be 2 pi r. All are constant, right? So don't differentiate n, okay, dn dt, as the wheel has a fixed radius. Perfect. So that is the relation which you get, and from here we need to find what dn dt is. So dn dt, of course, isolate that. So we get 1 over 2 pi r times dx dt. So you also notice that it is inversely proportional to the radius. If you have a bigger radius, the rate of change, the number of turns will be lesser, right? Because you cover more distance, right? So sometimes we could always change the question and ask you, how is this dn dt related with radius? If radius increases, dn dt increases or decreases, right? Okay. So anyway, this is what you get. And from here, we can substitute the values and find the answer. What we really need to find is dn dt. And so we'll just substitute these values here and get our answer. We know all of them. So dn dt is equal to 1 over 2 pi, radius is 70 for us. All, okay, so I did a mistake. So 70 centimeters, right? So we have to write this in centimeters, or we should be writing this in meters, right? So since I wrote 70 here, let me change this unit here. 5 meters per second really means 500 centimeters per second. Does it make sense to you? So we'll change dx dt to 500, and this is centimeters per second. Is that clear to you, right? So here, this is centimeters, right? So centimeter and centimeter will now cancel, and we will get number of turns per second which is required, correct? So that is what we have. It does make sense to you, right? So once again, let me rewrite this here very clearly. So we get rate of change of number of turns with time is indeed equals to 1 over 2 pi, in this case 70 centimeters, right, times 500 centimeters per second. Is that clear to you? So centimeter and centimeter cancel. So if you include units, you're not going to do the mistakes as could have been done, right? So let's use calculator this time. So we have 500 divided by 140. Okay. So you could write this as equal to, if they are asking for exact value, you can write this as 25 over 7 pi, right? So you could do this per second. Is that clear? Otherwise, we can actually divide this by pi and get it in decimals also, right? So dividing by pi equals to around 1.137. We get this in per second. Okay. Let's say per second. Number of turns per second. Is that clear to you? So that is how you could answer this question. Clear? Question number 5. Area of oil spill is increasing at the rate of 5 kilometers square per hour. So we are given, when we say kilometers, we are given this in 5 kilometers square per hour, right? So it is increase in area, so dA dt with time. So area of oil spill is increasing at this rate. How fast is the radius of the spill increasing when the area is? So we have to find dr dt when area is 16 pi kilometers square. Clear? So that is what we are interested in. Now as far as the circle goes, we know area is pi r square. So we relate circle with area and radius with a very simple relation, and that relation is area is pi r square. So if I find the derivative with respect to time, I get this as 2 pi r, right, dr dt. Now we need to find dr dt for a given area. So I get this as dr dt equals to 1 over 2 pi r times dA dt. Now in this you see you have r here, but we are given area. So that also reminds you of one thing, and that is very clear, that you need to find for this area what is the radius, right? So you need to find that. And therefore, we'll do our calculations here now. We say area is equal to pi r square, and we are given 16 pi. So comparing, we get r as equal to 4. Do you see that? So now we know that this rate of change of radius we need to find for r equals to 4. Do you understand? And now it is much simpler. So we can actually substitute 4 here. We know what dA dt is, and we can calculate. Perfect. So now let's find dr dt when r equals to 4, and it is equals to 1 over 2 pi times 4. We'll include all the units are same, kilometers, so it's perfectly fine for us, times 5, right? So what we get is 5 over 8 pi, right? And the units radius, kilometers, per time, hours. Is that clear to you? So 5 by 8 pi is your answer. If required in some significant numbers, let's say 3 significant places, you could divide using calculator and then write it down. Perfect. Okay. Question number 6 here is, the sides of an equilateral triangle are increasing at the rate of 10 centimeters per minute. At what rate is the area increasing when the perimeter of the triangle is 60 centimeters? So we have an equilateral triangle. So what is the area of an equilateral triangle? If I am given this side as x, then what is the area of the triangle? So you should know the formula, or you should be in a position to figure it out, right? So let's be very clear. If this is x, all sides are x, correct? All sides are x. So one thing, perimeter is 60, so that means 3x equals to 60. We're talking about x when it is 60 over 3. So we want x to be 20, right? Okay. The sides of an equilateral triangle are increasing at the rate of, so we know what is dx dt. So dx dt is 10 centimeters per minute. At what rate is area increasing? We want to find what is dA dt when perimeter is 60. So when perimeter equals to 60, or we can say x equals to 20. This is what we need to find. So I think that is a better approach. You write down whatever you have understood from the question first, and now figure out what could be the relation which can help you solve this related rates question, right? So this is the approach. Now, okay. So area of the triangle here is half of base times height. Now, what is the height? We know base is x. Well, in this case, this is a right angle triangle. This will be x by 2, right? And we know this side is square root 3 times x by 2. So when these angles are at 60 degrees. So you can use trigonometry or you could use Pythagorean theorem, anything, right? So the height, we know height is equals to, you can say square root of x square minus, you can do like this, and what you will get here by solving this 2 is, let's do it, okay, so this is 4, right? So we get 4x squared minus x squared over 4 when you square it, so which is 3x squared over 4 square root, and that gives you as equal to x by 2 square root 3. Perfect. So normally you should just know it, right? Now this is half of base is x and the height is x by 2 square root 3. So area of an equilateral triangle is always x squared by 4 square root 3 if the sides are x units. Perfect. Now we need to find change in area with time. So we say dA dt is equal to, derivative of this is 2x over, we have this number 4 square root 3, so which is x by 2 square root 3. Is that clear to you? So that becomes the area, and now we need to find what is this rate of change when x is 20. So let's substitute 20 now for x. So dA dt for x equals to 20 will be 20 over 2 square root 3, right, which is 10 square root 3, right? And the units are centimeters. Area will be centimeters square per minute. Do you see that? So you need to check the units and always include units in your solution. Perfect. So with this question, which was very interesting question, has been solved. Now let's move on and take a look at question number 7. Now I'd like you to pause your video at this stage. Do this question yourself. The 3 questions which the last 3 are slightly tricky. So I'd like you to think over all the concepts learned and then go for the solution. I'll just give you the solution in a second. Consider motion of a particle along the path 2y equals to x cubed minus 4. Find the points on the curve at which the y coordinate is changing 6 times as fast as the x coordinate. You can always pause the video, answer the question, and then look into my suggestions. So let's try to understand. We are given this function, which is 2y equals to x cubed minus 4. Now we're saying, find the points on the curve, there could be more than one, at which y coordinate is changing 6 times as fast as x coordinate. So when we talk about changing, we're saying changing with respect to time, because the particle is moving with respect to time, right? So y coordinate is changing 6 times as fast, means we are given that dy dt is equals to 6 times dx dt. Is that clear to you? Now that is a key to solve this question. Perfect. Once you understand this, the solution is very simple, right? So now let's figure this out. So once we know that, we know we'll begin with 2y equals to x cubed minus 4. We can differentiate both sides with respect to time, right? So if you do that, we get 2 dy dt equals to 3 x square dx dt. Derivative of 4 is 0. Now, we know that dy dt is 6 times dx dt, so we get 2 times 6 dx dt, correct? Let's put bracket here, equals to 3x square dx dt, clear? So we replace dy dt with 6 dx dt from here. Is it clear to you? And now we can actually cancel dx dt and we can find the value of x. So we have here 12 equals to 3x squared. So x squared is 12 by 3, which is equal to 4. And clearly plus minus 2, we get two values for x, correct? So we know the two values of x. Now we need to find the points, right? Find points. So to find the points, we'll substitute the value of x in our equation and then find the points, right? So we have the equation 2y equals to x cubed minus 4. We have y equals to half of x cubed minus 2. So if I substitute 2 here, we get y equals to half of 2 minus 2, which is minus 1. So that is 1 point. So we get a point which is for 2, it is minus 1. And now we'll substitute minus 2. So y equals to half of minus 2, right? So that is minus 1. That gives me minus 3. So the other point here is minus 2, minus 3. Is that clear to you? So we can now write down our answer that the 2 points are 2 minus 1 and minus 2 minus 3. Is that clear to you? So that is how you can actually solve this question. So I hope you find it interesting and useful. Now here is question number 8, which is a kite is 80 meters high and 100 meter of string is out. If the kite is moving away horizontally at the rate of 32 meters per second, find the rate at which the string is being pulled out. So think about it like this. Vertically, the kite is 80 meters high, right? So this is 80 meters. This is fixed. Now, the kite is moving away like this in this direction, right? Moving away horizontally, and this rate at which it is moving away, let's say dx dt, is equal to 32 meters per second, correct? And find the rate at which the string is being pulled out. So the string, you're holding the string somewhere here, for example, is 80 meters, so let's say like this. Okay. So that becomes 80 meters. So let this be y for you. So that is the situation. Perfect. So definitely that is at right angles. Now, looking into the situation clearly, we can say that x and y are related with the Pythagorean theorem right there, correct? So let's write down what we have. So we know that rate of change dx dt along horizontal is equal to 32 meters per second, right? And what we need to find is dy dt when the kite is 80 meters high and 100 meters of string is out. So when y is equal to 100. That is what we need to find, right? Now, to find this, we can relate, and we know what is y square equals to. Y square is equals to 80 square minus x, y square is the hypotenuse, is 80 square plus x square, right? So now differentiating with respect to time, we get 2y dy dt equals to, rate of change is 0 for this, right, plus 2x dx dt. So at this stage, we differentiate with respect to time and we get this result. We need to find what dy dt is. So dy dt is basically equal to 2x over 2y times dx dt. That's what it is. Now, of course, 2 and 2 will cancel. So we get our relation dy dt is x over y times dx dt. Now, in this relation, we have x also, right? Do you see that? But we know what y is. We have to figure out what x should be. So to find x, we'll have to use this relation and find what is x when y is 80, correct? That is the whole idea. So what we get here is we need to find what x is. So we'll work it out. So we know y is 100. So we have 100 square equals to, let's say, 80 square plus x square, right? So x square is equals to 100 minus 6400. And, x will be square root of this, which you know from your theorem 3, 4, 5, and this is 6, 8, and 10, right? So you get your result. So we are expecting 6 here, right? So we get x equals to 6 from this 60 rather, from the triangle. Let's do it. So we have here, let's use 100 minus 6400, correct? So we have 100 minus 6400 equals to, which is 3600, and we'll do square root of our answer to get 60. Perfect. So these values are taken so that you could easily solve, right? So we get 60 meters. That is the value of x. So basically, when we say find the rate at which the string is being pulled out, now that was when the string was 100 meters long. So x value is 60. So we'll put 60 here. So we can write down the rate as dy dt when y equals to 100. That means x is 60 will be, so substitute 60 for x and 100 for y, and rate of change is 32. Correct? So that gives you the answer. Right? So you can multiply by 2. 6 times 2 is 12, 2, 1. 6 times 3, 18, 19.2. And the units are meters per second. Is that clear to you? So that is how you could actually answer this question. The question here is, a ladder 5 meters long is leaning against a wall. The bottom of the ladder is pulled along the horizontal ground away at the rate of 6 meters per minute. How fast is its height decreasing when the foot of the ladder is 3 meters away from the wall? So let us say this is the ground, and let us say that is the wall. Now here is a ladder which is being pulled away, right? So that is the ladder. So we are given ladder 5 meters long. So this is 5 meters long. The bottom of the ladder is being pulled horizontally. That means we'll take this as x, we'll take that as y, right? So when we say the bottom of the ladder is being pulled horizontally along the ground at this rate, that means change in x. So we have dx dt is given to us as 6 meters per minute. How fast is its height decreasing? That means this y value. When the foot of the ladder is, so we need to find what is dy dt. So decreasing means it will be negative. How fast is height decreasing? When the foot is 3 meters away. When this is 3 meters away, that means x equals to 3. Correct? Now it's also a good idea to find what is y when x is 3, right? So in this particular situation, we know that the relation is x squared plus y squared is 5, correct? So we have here a relation which is x squared plus y squared equals to 5. So if x is 3, so it is 3 squared plus y squared equals to 5. You know it is 4. But anyway, let's do the calculations. So we have 25 minus 9, which is 16. And definitely we are going to take positive value since the distance is positive. So y is 4 for x equals to 3, right? So we know the points is 3 and 4 for us. Is that clear to you? Now this is important since the relation may involve both x and y. as you've seen, right? Now, in every rate of change, we have to write a relation which relates both of them. So we can say that x square plus y square is equal to 5 square. So that becomes the relation. So in rate of change, we'll differentiate with respect to time, correct? So if you do that, differentiating this, we get 2x dx dt, right? Plus 2y dy dt is equal to, this will be 0. It's a constant. We need to find what dy dt is, so we'll isolate this. So we get 2y dy dt is equal to minus 2x dx dt. Now 2 and 2 cancel, so we can say dy dt is basically equal to minus x over y dx dt. So since we need to find what is this value dy dt when x equals to 3, and we also found that y value is 4, right? So substituting them, we get minus 3 over 4 times dx dt, which is given to us as 6 meters per minute, right? So that becomes the units. So we can now do the calculation. So it is when you divide 18 by 4, right? So it is negative, or you can write this as 2 and 3. So we get 3 times 3, 9 by 2. So minus 9 by 2 meters per minute, or you could write it in decimals, minus 4.5 meters per minute, right? So our answer here clearly is, it says, how fast is its height decreasing? Now negative means decreasing, so when you say height is decreasing, at the rate of, you don't have to write negative because we have qualified with the word decreasing. So we'll write 4.5 meters per minute, right? So that is kind of important to understand. So when you use the word decreasing, that means you've already covered for negative, correct? So the answer should not include minus at this stage. Is that clear to you? So that is how we are going to solve such a question. Two cars are moving at constant speed of 60 kilometers per hour along straight roads inclined at 45 degrees from their starting point. Find the rate at which they are separated. You can always pause the video, answer this question, and then look into my suggestions. So let's try to sketch the scenario and understand the position. So there are, from this point, let's say there are two cars. One is moving in this direction, the other one 45 degrees, right? Now they are moving at the same speed, so with time they'll cover the same distance. So let's say one car reaches here at any instance of time. The other car will also reach as far, but on the horizontally going road, so that is the position X. What we are interested in finding out is what is their separation, right? What is the distance between them at any instance of time, and how is this distance changing, correct? We know that the angle is 45 degrees between the two roads. So basically we have an isosceles triangle, as you can see, right? So in this particular triangle we have one angle as 45 degrees, and that is the situation. Perfect. So you can actually now use a bit of trigonometry and then solve this question. Now a good reminder here is that in trigonometry, when you are trying to solve a triangle where two sides and an angle is given, the situation is SAS, right? In that case, you use cosine law. Perfect. So we are going to use the cosine law to find D. So distance D will be equal to, they are related as D square equals to, in this case, x square plus x square minus 2 times these times cos of the angle in between, right? So that is straight from cosine law. Perfect. So that is how D will be related with that distance, right? So in our case, we get d square equals to 2 times x square minus 2x square, and cos 45 is 1 over square root 2. So you could write this as d square equals to 2 times x square minus square root 2 x square. Or we know d is square root of all this. So x square is common. So we can write this as 2 minus square root of 2. X square root is x. Is that clear to you? So that is how d is related. The separation between the cars is related with distance they have moved, right? Correct? Now we are saying two cars are moving at a constant speed of 60 kilometers per hour. So that really means that change in distance dx dt is 60 kilometers per hour. Clear? So we know the change in distance, and we need to find the rate at which they are being separated. So we really find d distance d, which we took here, over dt, right? This is what we need to find, a general expression. Is that clear to you, right? So that is the question for us. Okay. So now we know the relation, so let's find derivative. So d is equal to 2 minus square root of 2 times x. So if I differentiate with respect to time, so d dx, d dt of this d, right, of this d, which is separate, right, this d, separation, is equal to, that is a constant, so we'll have this constant very much there, right, and this will be x derivative is 1 dx dt. So we get our relation. Perfect. So at any instance of time, that is how they are related. And dx dt is 60 for us. So we can say, so the separation d, right, this distance change between the two cars is square root of 2 minus square root of 2. Dx dt in our case is 60. And the units will be kilometers per hour. Is that clear to you? So that is how we'll actually solve this question. So I hope the steps are absolutely clear. You can use the calculator to write approximate value. However, this is the required solution. Now sometimes we can always change the speed of these cars. We can say twice as fast, then these parameters will accordingly change, and you can solve such a question also, right? So let me make a variation here. Question number 10b. So if say car 1 is going at let's say x, let's say velocity v kilometers per hour, and car 2 is twice kilometers per hour, find rate of change of separation. So try this question. Is it okay? So find rate of change of separation. Okay, I hope you have understood the concept. Feel free to write a comment, share your views. You can actually look into other related worksheets. They should really definitely help you. Thanks for your time and all the best.